Okay, today we are going to learn physical properties of halogenated compound. Now in that, first point is physical appearance. Now it is written that bromide and iodide, they develop some color in light. In presence of light only, they will have color. Iodine is violet in color and bromide are slightly yellow in color. Other than that, chlorinated compounds are colorless. Next one is melting point and boiling point. Now here order is given to you. Iodide compound that are having more melting point and boiling point, then bromide, then chloride, and last one fluoride. So least boiling point is of fluoride. Now why is that? So iodide compound, they have more number of electrons in it. Due to that more number of electrons, van der Waals force is greater than others. So due to van der Waals force, strong van der Waals force, this iodide compound have high melting point and boiling point. Now suppose we have some branch in our compound. You can see the example first. This first compound, it has 3 carbons and a bromine in linear manner in a single line. So it is only one branch here. So boiling point is 375 Kelvin. Now if you see this compound, it has 4 carbons, means number of carbon increases here, and branch is 1, 2 and 3 branch are there. So it has boiling point 364. Now here you can see it has 4 number of carbon, that's why the boiling point is higher. Boiling point is lower here. Now look at the third structure. It has 4 branches and number of branch increases, so boiling point decreases. Boiling point is 346 Kelvin here. You can see 4 branch are there, so boiling point decreases to 346 Kelvin. So it is written that boiling point decreases as number of branch increases. Again, boiling point decreases as number of branch increases in the compound. Next, if we have aromatic halides, it is written here 3 aromatic halides are here. First one, it has 1,2 position, 1,2 dihalobenzene is there. Second one, 1,3 position is there, means meta position. And the last one is para position. First one is ortho. Now in that para position means this last structure, it has highest melting point. Why? So here these 2 chlorines are far from each other. That's why it is somehow stabilizes itself, because chlorine has lone pair of electrons and they are far from each other. So repulsion is less compared to these both. Repulsion between electron is less compared to these both. So it is somehow stable compared to this both. That's why it has high melting point. Next point is density. Now in density, the point is like this. Density increases with increase in carbon or halogen. Look at the example here. First structure, it is chloromethane. It has 1 halogen in it. And this one is methane, simply methane, CH4. Now halogen is 1 here and halogen is 0 in this structure. So it has low density than this one, chloromethane. Now look at the second structure. The number of halogen increases here. Here 3 halogens are there and 1 halogen is here. So density will increase with increase in halogen, or density increases with increase in carbon also. Suppose if I take ethane, chloroethane instead of this CHCl3, so number of carbon also increases. So in case of that, ethane has higher density. Suppose I am comparing these both compound. Now in case of this, you can see number of carbon increase in second structure. So this one will have high density compared to first one. The next point is solubility. Now most of the haloalkanes are very slightly soluble in water, means almost insoluble, but they are soluble in organic solvents. Now why is that? So here you can see the bond between halogen and carbon, it is polar bond, so it is strong bond. Now to dissolve it in water, we have to break that bond and make some ion, but in water the bond is strong, that's why the bond does not break and it does not make any ions, so it is insoluble in water. But in organic solvent they get enough energy, so it can make 2 ions in organic solvents. So it is soluble in organic solvent but almost insoluble in water. Now next topic is nucleophilic substitution. Now what are nucleophilic? So species that attracts towards nucleus, that are nucleophilics. Now in nucleus proton is there, so you can say that species that attracts towards proton, positively charged particle, that are called nucleophiles. So they must have negative charge on it. Again, negatively charged compound, they are nucleophiles. Now here you can see in CX bond, halogen is having partially negative charge and carbon is having partially positive charge. So when nucleophile, means negatively charged compound, attacks, it will attack on carbon, not on halogen. Again, negatively charged compound ion will attack on carbon, not on halogen. So we can easily replace this new nucleophile with halogen. You can see the reaction. C nucleophile bond is newly formed here and halogen is removed. So this type of reaction, it is called nucleophilic substitution reaction. It is substitution reaction and nucleophile is attacking here. So it is nucleophilic substitution reaction. Now in halogen, this carbon is known as nucleophilic center because nucleophile attacks on this carbon. That's why carbon is nucleophilic center here. Now there are some groups that have 2 nucleophilic center in it. Suppose I am taking this cyanide here. Now cyanide has resonance structure. You can see the resonance structure here. So this cyanide, in cyanide, nucleophile can attack on this carbon as well as nitrogen. So it has 2 nucleophilic center. So they are called ambient nucleophile. Again, ambient nucleophile.